In-depth explanation of context in Go. The context package in Go is a powerful tool designed to manage goroutines, ensuring clean and efficient concurrent programming. It provides control over timeouts, cancellations, and value propagation, making it essential for scalable and robust applications. What is context in Go? Context is a construct that helps manage the lifecycle of goroutines and other resources. When multiple goroutines work on a shared task, context acts as the orchestrator, coordinating their behavior by canceling operations when they're no longer needed, enforcing timeouts to prevent tasks from running indefinitely, passing lightweight data like request IDs to downstream processes. How context works? Context revolves around the context.Context interface, which defines methods for handling timeouts, cancellations, and values. 1. Cancellation signals. If a parent goroutine signals cancellation, all its associated child goroutines are notified and terminate gracefully. 2. Deadlines and timeouts. You can enforce deadlines or time limits on tasks, automatically stopping operations that exceed the allowed time. 3. Value passing. Context provides a safe mechanism for passing request-scoped values, avoiding global variables. Types of contexts. 1. Root contexts. Context.Background, used as a starting point for creating derived contexts. It's a blank slate with no deadline, cancellation, or values. Context.TODO acts as a placeholder when you're unsure which context to use. It's commonly used during development. 2. Derived contexts. Derived contexts are created from a parent context and inherit its properties. These include WithCancel, adds cancellation capability to a context. It provides a cancel function that, when invoked, stops all operations tied to the context. WithTimeout adds a timeout to the context. If the operation exceeds the specified duration, the context cancels automatically. WithDeadline, similar to WithTimeout, but lets you specify a fixed point in time for the context to cancel. WithValue allows you to attach key value pairs to the context. This is useful for passing metadata, such as authentication tokens or trace IDs, across functions. Traffic lifecycle of a context. 1. Creation. Start with a root context using context.Background. Derive child contexts using WithCancel, WithTimeout, WithDeadline, or WithValue. 2. Propagation. Pass the context to functions or goroutines that need to share cancellation, timeout, or values. 3. Cancellation. When the parent context is canceled, all derived contexts are notified and their goroutines terminate. 4. Cleanup. Always call the cancel function to free resources associated with a context. Key features of context. 1. Cancellation propagation. Context allows a parent goroutine to signal its child goroutines to stop. This is useful for graceful shutdowns, preventing resource leaks, terminating dependent operations. 2. Deadlines and timeouts. Deadlines ensure that operations complete by a specified time. Timeouts automatically stop long-running operations after a set duration. 3. Scoped data passing. Context enables you to pass small pieces of data safely between functions, such as user credentials, trace IDs, or configuration parameters. Practical use cases. 1. HTTP servers. When a client disconnects or a request times out, the server can cancel all associated goroutines using the context. This prevents unnecessary resource usage. 2. Batch processing. Contexts help manage worker pools, ensuring that tasks terminate gracefully during shutdowns or when processing is no longer required. 3. Distributed systems. In microservices, contexts are used to enforce deadlines across service boundaries and share metadata like trace IDs. 4. Event-driven systems. Contexts manage the lifecycle of asynchronous tasks, ensuring proper cancellation and cleanup. Best practices. 1. Pass context first. Always pass context.Context as the first parameter in your functions. 2. Use scoped data carefully. Avoid overloading context with data. It's not a replacement for structured data. 3. Always cancel contexts. Ensure you call the cancel function to release resources. 4. Avoid nesting too many contexts. Keep the context hierarchy manageable to avoid complexity. Common misconceptions. Context is for data storage. While WithValue allows passing values, context should only carry lightweight request-scoped data. Contexts clean up themselves. Developers must explicitly call cancel to free up resources. Conclusion. The context package is a cornerstone of Go's concurrency model. By managing cancellations, deadlines, and values, it enables clean, efficient, and scalable goroutine management. Whether you're building web servers, distributed systems, or event-driven architectures, understanding how to use context effectively is essential for writing robust and maintainable Go programs.